Okay, class, welcome to lecture 13. Today we're going to talk about more examples of normal probability distributions. And I'm currently at a hotel with a new setup, and I'll let you guess why I'm here. So I hope this works as well as my usual setup. I had to use a laptop, and the iPad won't share its screen properly, so I have to join the Zoom session with the iPad separately. Try it like that. Okay, so we'll see how it goes. Luckily, this lecture isn't too long, and it's just examples. Okay, so we're going to do examples of what we learned last time. So here is the first one. So the idea is, the idea is that if you have some data that's modeled by a normal distribution, you can do what we're going to do here. So here's one example. Heights of 3-year-old children are modeled by a normal distribution, so I'm allowed to use the math we just learned. Or sometimes I don't call them normal probability distributions, I just call them normal distributions to save time. Okay, and with a normal distribution comes a mean. So I have to have a mean, and I have to have a standard deviation. So remember, that's what allows us to draw the picture, the appropriate bell curve. So this is in inches. So 3-year-olds are average this long, I guess, and this is their standard deviation. Those heights. Okay. So we're going to try to answer the question. 3-year-olds. So find the percentage of 3-year-olds with height less than 35 inches. So the key here is I'm finding a percentage, but percentage is just another way of thinking of probability. So I can use all the stuff I did last time. All right, so I'm going to try to break it down into very specific steps that you can reuse for other problems. But what we're going to do first is we're going to draw the appropriate normal distribution. The laptop fan is just turned on. It's hot, so hopefully, I don't know, it's not too loud. Okay. So draw the normal distribution. Which just means draw a bell curve however you want and write the mean that's given to you in the middle, label where the inflection points are. So you have to add one standard deviation to go to the right, so I got to add 3.17. You can use a calculator, of course, for this purpose. 31.9, and you have to subtract one standard deviation to get this inflection point, 35.59. Okay, and now I'm going to shade the desired region. So what I'm trying to do is I'm trying to find the percentage of 3-year-olds whose height is less than 35 inches. That means I want to find where 35 is. Just estimate doesn't be perfect. And I'll shade what I'm looking for. So since I want less than, I want the probability that if I pick a 3-year-old randomly, the height will be less than 35 inches. That's another way of asking this question. That means I want to find the shaded area to the left of 35. So that's the area that I'm looking for. And that will correspond to the percentage answering the question. Okay, so that's the idea. So I shaded the desired region. Okay. So now I'm just sort of going to rephrase things. So I want the area below. So I'm going to use fancy math terminology. So what's going on is 35 is one of the possible values of the random variable x. So what I can do is I can call my little x 35. So because it is one of the value that the random variable x can be, so I can think of this as the heights of the 3-year-olds. That's my random variable x. Okay. So all I'm doing is bringing a fancy math language to this to make it a little bit more tricky. So what we need, but it also helps us in a second. So we need the z-score for, you can think of it as the data point x equals 35. And that makes it a little bit easier to set up. So that just means I need to do z equals 35 minus the mean over the standard deviation. Well, we have the mean, 8.72 divided by the standard deviation is 3.17. So let's set a calculator and just do that real quick. You get negative 1.17. So that's the z-score. So remember what's going on is there's this other distribution, just that z-scores, that corresponds to the one we drew. And then what we're saying is that this z-score is negative 0.97, corresponding to the data point 35. So now we're going to find the area of that shaded region by using an online calculator. So now I convert to probability using an online tool. So I linked one on Moodle, and all you have to do on that one is you just have to type in this number, and it'll tell you the cumulative probability, which is the same as the area to the left. It'll tell you it's 0.1210. So this is basically the answer, but to be a stats answer, you have to really interpret it in context. So this is how much area there is in this red shaded region. 0.1210. But you can't just leave it at that because it's a stats class, not a math class. So I have to answer in context to really be done. That's what we'll do. So let's say it like this. There's other ways to say it, but you gotta say it sort of similarly at least. So it's 0.1210 area below 35, the data point is at 35. This means that the percentage of 3-year-olds below 35 inches in height is, well, I just change that probability or area into percentage, 12.10%. Now, this complete sentence is the answer. So you gotta write a complete sentence as your answer, or I'm not gonna take it. Okay. All right, let's just do another one, slightly harder one. So this is sort of how my classes go. Go from easiest to hardest. So use the same exact setup, find the probability that a 3-year-old is between 35 and 40 inches. So it's the same exact one as before. So I have this L curve still. I don't want to relabel it again. You can look at yours, you already have it. This is 38.72 at least. And now I want to find, so we're going to combine the steps. I'm going to shade the region immediately. So 35, we already know is roughly right there, because this is the first standard deviation. Is it 35.59? And I guess I do need to go above. Let's do 41.89. So I want to go between 35 and 40 this time. So this is the area that I'm looking at. So that's really the area that I want. So what I can do is something very similar to last time, but it's going to be a little bit extra steps. Oops. So what can I do? Well, I have to use some other math. So first I'm going to convert 35 and 40 into z-scores. But because there's two values of little x that the random variable is going to be in this situation, what people do is they call them x1 and x2. So you put a little subscript to keep them separated. And then the z-scores, you'll call them z1 and z2 to keep track of which goes with which. So I'm going to find the z-score for 35, which we already did earlier. Let me write it here. So it's negative 1.17. And then I'll find the z-score for 40. Same exact process. So what this means is on the side, you don't really have to do this part every single time, but again, just to remind you, we're really looking for the area in terms of z-scores. And so what we can do is use the online calculator that knows that already for us. All right. Can be a little bit different. Okay, so we already know that the area to the left from the previous part of this guy was 0.1210. So that we looked at before. So now let's do the other one. So you look up in the online tool, and you'll get area to the left. Z equals Z2 equals 0.4. You'll end up with 0.6554. So let's just draw out what's going on here real quick. So the idea basically is that we have this area, it's 0.1210. Very sketchy. And this area is 0.6554. And the area that I want is the area betwixt them and between them. So what does that mean? Well, that means that I want to like get rid of this area, because then I'll be left over with just the area that I want. So how can I do that? Well, all I have to do is subtract. So the area between, sorry, this hotel that I have picked microwave beeps on its own all day. Interesting. Okay, so then the area between 35 and 40, or the two z-scores, it's going to be the bigger area, the big giant one on the right, 6554. And then you just take away the smaller area. You'll be left over with the blue area in the middle. So 0.5344. So again, we're done, but let's see, did I label this as 4? But now I got to answer in context. So the probability of a 3-year-old being between 35 and 40 inches is this probability that I just found. Okay, so that's it. That's what I hope. Okay, so now let's see. We're going to do slightly more complicated questions where we go backwards a bit. The fridge just turned on, so I'm going to turn off the recording and make a new one instead. Too loud.